The authors acknowledge that this podcast was recorded on the traditional, unceded lands of the Lekwungen peoples.
Hello, and welcome back to another episode of Stories from Space. I'm your host, Matt Williams. And today, at long last, I am going to be covering a topic that I've been promising to cover for so very long, but it just getting pushed to the back burner. And that topic is panspermia. However, first, a little bit of housekeeping. I wanted to announce with this episode that Stories from Space has migrated from its old platform, ITSP Magazine, to Patreon, where it is now an independent podcast funded, fueled, and kept ad-free by patrons like you. So to all those who've already signed on, I thank you from the bottom of my heart. And a special shout out to David Henry, who has become my first paid subscriber. And I'd just like to mention to everyone listening that subscription comes in many forms. For a $2 monthly donation, you can be a Stargazer sponsor, in which you'll be funding ad-free content. A satellite sponsor for $5 will get you regular updates on new episodes and the occasional shout out in our newsletter. Planetary sponsors for $10 a month, all of the aforementioned benefits, and you'll also have access to exclusive interviews with some of today's top scientists and luminaries. Examples including Harold Sonny White, formerly of NASA EagleWorks, now at Limitless Space, who's researching the Alcubierre warp metric for the sake of going faster than the speed of light. Marshall Eubanks of the Initiative for Interstellar Studies, who's developing concepts for traveling to the nearest star system as well as catching up with interstellar objects like Oumuamua. And also Robin Hansen, the man who came up with the Great Filter hypothesis himself, and Professor Avi Loeb, who suggested that the interstellar object of Oumuamua might actually be an artificial extraterrestrial object. But there's more. For $20 a month, you'll become a stellar sponsor, in which you'll have access to not only the exclusive interviews, but also special video content, which will be featured in this episode and has been in previous episodes now. And last, there is the Galactic sponsor. For $50 a month, you'll receive all the previous mentioned benefits, as well as book reviews, limited release episodes, and other bonus content. And if someday I start merchandising, well, that'll be included among these benefits. And if you were listening closely, you may have noticed this whole tiered sponsorship thing was inspired by the Kardashev scale. I had to get a little bit creative with the smaller range sponsors there, but yes, planetary, stellar, and galactic, that's all Kardashev, baby. And with that taken care of, I now turn to the subject of panspermia. And I do hope that paid subscribers will enjoy the video that follows. This is quite the fascinating topic, and I was certainly very interested in finding animations and any footage I can that address the idea of interstellar objects, interstellar comets, asteroids, and rogue planets, and also hypervelocity stars with gravitationally bound planets, because all of these have something to do with the theory of panspermia. And to give it to you simply, panspermia is the theory that life in our universe is distributed throughout by objects such as interstellar comets, asteroids, rogue planets, and as of a few years ago, even hypervelocity stars that have been kicked out of their home systems and have brought their planets along with them for the ride. And that all of these could constitute a means of transferring biological material, organic molecules, and the building blocks of life itself from one star system to another, but also to another galaxy. And the theory takes its cue from the earlier theory known as Lithopanspermia, which basically stated that life and the ingredients thereof could have been distributed throughout the solar system by rocks that were ejected from one planet, from an impact from an asteroid, which then found their way to another planet, crashed on the surface, and was able to distribute any organic material that they happen to have on board. And that is a theory that goes back to the late 20th century, in which scientists examining meteorites that they knew had come from Mars actually did contain organic material. And so this gave rise to a theory that, in fact, the ingredients for life came to Earth from Mars, or perhaps elsewhere in the solar system. And that theory has matured somewhat because scientists, until very recently, they were of the general consensus that water, as well as organic molecules, that these were brought to Earth early in the history of the solar system by icy objects from the outer solar system, and that this would have occurred during the late heavy bombardment period, roughly 4 billion years ago. And as the name suggests, this was a time of increased comet and asteroid activity. The solar system was still in the process of formation, and planets were migrating, and so rocks and planetoids and icy bodies, asteroids, they were being kicked around all the time, and that this was an explanation for how planets in the inner solar system were able to retain water on their surfaces. And forming from these molten balls of metal and silicate minerals, volatiles like water would have been boiled off and lost to space. So the idea then became, after the planets had formed, water would have been reintroduced. And the theory certainly carries a lot of weight because, of course, the impact history of the moon and bodies like Mars, where evidence of ancient impacts have been perfectly preserved, unlike on Earth, where weather and geological activity are constantly changing and weathering the surface and renewing it. And on a related note, as I mentioned in the episode on asteroid mining, this is also the same way that precious metals and other heavier elements, they were introduced to the surface of the rocky planets during much the same period by the rockier, heavier asteroids. They brought along trace metals, which they deposited into the lithosphere, and the reason why that is the source of our metals from which we mine is because all of Earth's original metal content, and same with Venus, Mars, and Mercury, it migrated into the interior to form the core. So were it not for the late heavy bombardment period, we would not be mining at all. We would be using rocks as tools and bones and flint still. In other words, there would be no metals accessible to early humans. So you could in fact say that everything that made Earth what it is today, a life-giving, life-bearing planet that supported not only the emergence of life and complex life, but the maturation of hominids into modern human beings. This came from space. And as I said, this was up until fairly recently that scientists were of this general consensus, which is to say it hasn't been disproven, just that the timing of the delivery of water from the outer solar system may have happened more gradually, and also that a lot of the necessary ingredients for life, the organic molecules, actually came from closer to home. But the point remains. Life down here began out there, in the sense that the building blocks originated from space and were delivered here by asteroids, comets, and planetoids. And what's more, the subject of panspermia and the possible role that interstellar objects may have played in the distribution of life throughout the universe, it's received renewed interest thanks to the first detections of interstellar objects entering our solar system. And of course, this began back in 2017 with Oumuamua, the Hawaiian term for scout, a name that was assigned long before Professor Avilob made his controversial suggestion that it might have been a derelict probe or a piece of space debris from another civilization. It also picked up the nickname Rama before he made any such declaration, so both names proved to be a bit prescient. In any case, this was the first ever confirmed interstellar object, or ISO for short. and much of the ambiguity surrounding what it was. This was the result of astronomers only having a few days. There was an 80-day window during which Oumuamua was observable, but of course its very rapid speed and the way it began to rapidly dim essentially meant that the scientific returns were limited. Nevertheless, the mere fact that Oumuamua was detected, it signaled two things. One, interstellar objects are statistically significant, meaning there had to be a population in the billions. And in fact, by their calculations, scientists determined that about 7 a year enter and leave our solar system, although some actually would be captured by Jupiter or another planet's gravity and would remain. So billions of these objects exist in our galaxy and travel between systems on a regular basis. That's what the detection of this one object implied. The other big takeaway from this was that our instruments had now achieved a level of sophistication that we would be able to spot more of them in the future. So there was quite a bit of anticipation, and lo and behold, 2 years later, Borisov showed up. 2I Borisov. Second object of its kind that was detected, and I indicating its interstellar classification. And Borisov, after the astronomer, who was Ukrainian, who first spotted it and reported it. And as I said, the subsequent detections, they not only confirmed that these objects are quite abundant, and that we would be seeing more of them. And of course, it also confirmed that, yes, our imaging techniques, our astronomers, they're up to the task. And that was especially evident by the way Borisov was detected while it was still on approach to our sun, which was not the case with Oumuamua. It was spotted by accident after it already made its closest pass to the sun and was on its way out of the solar system. And so scientists had an opportunity to observe Borisov during approach, and they were able to see and determine with certainty that it was a comet, because the moment it was within the inner solar system, the moment it was exposed to enough sunlight, it began to sublimate. Basically, the frozen water and other volatile compounds that make up its surface composition there, they began to outgas. They don't turn into liquid form or melt in space, they just go straight to vapor. And third, we had Atlas III, which of course inspired no shortage of controversy as well, but nevertheless, once again, scientists, due to the fact that they were able to detect it long before it swung around the sun, they were able to get a pristine view of it as it began to puff out water and carbon dioxide. And what was very interesting was the observations that happened after it had passed behind the sun in December of 2025. As it made its way out, it was outgassing more intensely, but scientists, by measuring the spectra of all that outgassing as it captured sunlight, they were able to determine that this was coming from its interior now. When it was on approach, it was shedding its outer layers, and those layers were made up of ice that had been bombarded by cosmic rays and dust and small impactors that are common in the interstellar medium. And now, what it was spewing forth came from deep in its interior, so material that had been preserved for just billions of years. And that told scientists quite a lot about it. In any case, scientists have investigated these and other objects, in particular long-period comets that come from the outer solar system, as well as near-Earth asteroids. There's been a bunch of sample return missions lately, and that includes Hayabusa 1 and 2 from the Japanese Space Agency, and of course NASA's OSIRIS-REx. Now, what these samples revealed was that, in fact, the building blocks of life are present in these objects, and they are stable. And we're not just talking about organic molecules and the precursors to the building blocks of life. We're talking amino acids, which have also been observed forming spontaneously in space, whether it's in the interstellar medium or in nebulae. It does seem like the universe, it does create everything that life needs under the most heinous and difficult of conditions, which are then distributed readily by all these stray objects. And two other developments, which have happened in recent years and have drawn more attention and credibility to the panspermia theory, although these were not nearly as sensational as Oumuamua, Borisov, and 3I Atlas. But nevertheless, scientists were able to confirm the existence of rogue planets. So planets that get kicked out of their respective solar systems, which, based on the study of exoplanet systems and ongoing research into the solar system, it does seem like that is a common thing with early solar systems, where the planets have formed, but they will be subject to migration. They're trying to find their final stable orbit. And many of them end up either being consumed by the sun or they are ejected. And much like interstellar objects, the existence of rogue planets, it was predicted beforehand. And the very first confirmed detection was in 2000. But the discovery process has really ramped up, and many, many, many more candidates have been observed in recent years. In fact, the James Webb Telescope, its dedicated observation time to looking for rogue planets, and it was successful. It reported the existence of several more that were floating in the interstellar medium. And the interesting thing about that, obviously, is, well, if interstellar objects, comets and asteroids, if they can carry the seeds of life from place to place, couldn't these too? And in the case of the many gas giants that have been spotted in interstellar space, scientists have also wondered, well, much like Jupiter and Saturn, could its moons, assuming it carried along its system of moons, would they not also be subject to tidal flexing in their interior, which could create energy and heat that would be enough to melt the ice on these moons at the coromantal boundary, creating interior oceans? And if, in fact, moons like Europa and Titan and Enceladus, and the evidence is strongly indicating that this very well could be the case, if they do in fact support the existence of microbial life, simple life in their interiors, that thrives off of the chemicals being released by hydrothermal vents and the heat and energy that's also being released, would that mean that these moons and their planets were also spreading life throughout the galaxy? But as I said, there were two major developments, one being rogue planets, the other being unbound stars, which is to say stars that get kicked out of the Milky Way, or that are no longer gravitationally bound to it in the same way stars in the disk are, and that which periodically loop around throughout the Milky Way, and in some cases, carrying their planets along with them. And I can remember seeing a study about this. This was by Professor Avi Loeb, the same man who suggested the controversial theory about Oumuamua and 3I Atlas. This was back in 2014, I believe, and he was doing simulations that said that hypervelocity stars, a special kind of unbound star that would actually get kicked clear of the galaxy, that intergalactic space would be filled with these, and that they likely carry their planets along with them, because their planets are still gravitationally bound to the star. It's just the star itself, possibly due to galactic mergers or interaction with a supermassive black hole at the center of the galaxy, or even in the case with binaries that get spun up too fast and one gets kicked out. They would become unbound and would bring their systems along with them, including any habitable planets that might support life. And like just about everything else in multiple fields of astronomy in the past few decades, there's been a rather significant explosion in the number of confirmed unbound and hypervelocity stars. And so what this implies here is that if interstellar objects ranging from comets and asteroids to rogue planets are distributing life throughout individual galaxies and potentially their satellite galaxies as well, then hypervelocity stars, the ones that get booted out and carry their planets along with them, they could very well be the means through which life is spread from one galaxy to another. And this is really, really very exciting news in a sense, because it would indicate that common ancestry in the universe is a thing. And it could also mean that, if not common ancestry, at least life has common elements, so that life as we know it here on Earth may actually be somewhat indicative of the norm, which is to say at its most elemental levels, right? Comes down to amino acids and proteins, and ultimately it will use whatever is there in the local environment, and if the resources are sufficient, it will form complex organisms there which could eventually give way to intelligence. And when you combine that, when you look at the basic ingredients for life in the universe, which is to say they're everywhere in abundance as far as we can tell, it does create a somewhat optimistic picture for the existence of life beyond Earth. It's like not only are the elements everywhere, but we know for a fact that they're getting distributed throughout the universe from one place to another. So if any place is missing some of these key elements for life, you can bet your bottom dollar it's going to get it delivered at some point. You could say interstellar objects are very much the Amazon delivery system of the cosmos. Except the timescales are much, much different, and, of course, yeah, they don't get paid. And, of course, mustn't forget intergalactic objects. Need to add that to the list. And, as I mentioned, scientists now estimate that 7 interstellar objects enter the solar system with every passing year. Now, doing the math, our solar system has been around for 4.5 billion years, give or take. You come up with a gargantuan figure of objects that have passed through our solar system. And like I said, the calculations and simulations indicate that some of these objects have stayed over time and became part of the regular populations of objects that are distributed throughout the solar system. Some would become near-Earth objects, others would form orbits around Jupiter and the gas giants. Jupiter's families of Trojans and Greeks are actually one place that scientists want to look for interstellar objects. In fact, some studies have identified individual ones themselves as targets for future research. And I'd be remiss if I didn't say that if Professor Loeb is correct, and that some of these could in fact be objects of extraterrestrial design, that they could be in fact debris, litter, space junk that went from one system to the next, similar to what our Voyager and Pioneer probes will be identified as someday if they're found, then statistically speaking, there's a good chance that a tiny few perhaps, but given the numbers involved, a statistically significant number might in fact turn out to be alien junk. And simply one sample of that, one indication that an object in space is actually not a naturally occurring object, and we didn't build it, and we didn't send it there, that would end the debate once and for all. Is there intelligent life out there in the universe? Yes, there is. Somebody built this. And whether or not they're alive now, that remains to be seen. In fact, I do believe that at some point humanity is going to find unambiguous evidence of intelligent life out there, and the debate will shift from are we alone in the universe to are we currently alone in the universe, or rather just our galaxy, our small corner of it. In other words, are any advanced civilizations out there that are currently still alive? And that will become the new debate, the new SETI paradox or SETI conundrum. Last, all we can do is keep looking, and in the coming years, we are bound to encounter additional interstellar visitors and what we are learning about them and about the conditions under which they formed, so the conditions present in their star system at the time of their formation, has been pretty staggering. And of course, any discussion involving interstellar objects, it always comes back to Vera C. Rubin. The Vera C. Rubin Observatory, it is anticipated to find thousands of such objects in our solar system. It will be doing a huge inventory of all the planets and all the comets and asteroids. And so scientists expect that a lot of former interstellar objects, which have since settled into the solar system, they're going to turn up. And so we will naturally be looking at missions that'll go explore them up close, take samples, which is sure to reveal a great deal more about other star systems. And that's one of the beauties of interstellar objects, right? It's the fact that studying them will tell you about what another star system is like without having to send a mission there yourself. Very, very time and energy consuming process. And let me just end this episode by saying thank you to all my listeners who have patiently waited for it to finally drop. I know I kept promising it. I'm not sure anyone was particularly eager to hear about it, but yes, it was a promise I kept making, and somehow it kept getting waylaid, so very happy to bring it to you now. And I hope you'll tune in again soon. Season 6 is just now starting with this inaugural episode, and there are plenty more planned. Not the least of which will be some exciting interviews with guests that I am still in the process of booking, so I won't announce any names just yet. And more digressions and dissertations on various cosmological mysteries and recent developments, which include, of course, NASA's recent decision, which was to delay the Gateway and focus on building a surface lunar base, as well as some controversy regarding the crew of the Artemis 3 mission and what they hope to accomplish. In the meantime, thank you for listening. I'm Matt Williams, and this has been Stories from Space.